ME 8593 Design of Machine Elements. Unit 3 Temporary and Permanent Joints. Threader Fasteners. Hello students, here in this video we can see the tutorial problem, simple tutorial problems presented by Department of Mechanical Engineering, Thandai Periyar Government Institute of Technology, Vellore. The problem 1. An electric motor weighing 10 kN is lifted by means of an eye bolt as shown in figure. This is the eye bolt. The eye bolt is screwed onto the frame of the motor. The eye bolt has coarse thread. It is made of plain carbon steel 30C8. It is yield strength is 400 Newton per millimeter square and the factor of safety is 6. Determine the size of the bolt. What they are asking in this problem, the electric motor is weighing by eye bolt. The electric motor weight is 10 kN. Okay. The eye bolt is screwed onto the frame of the motor. The eye bolt has a coarse thread. This is the coarse thread, not a fine thread. It is made of plain carbon steel. The material of the eye bolt is plain carbon steel. The strength of the yield strength of the material is 400 Newton per millimeter square and the factor of safety is 6. Determine the size of the bolt. That means nominal diameter of the bolt. You have to find the nominal diameter of the bolt or outer diameter of the bolt. First of all, given data, P equal to 10 kN. P is the weight, load, and is OET. That means yield strength. Yield strength is 400 Newton per millimeter square. Fs, factor of safety, is equal to 5. Now we go to solution. The eye bolt is the used for lifting and transporting heavy machinery on the shop floor. The eye bolts are the uses of eye bolt is lifting and transporting the heavy machineries in the machine shop or floor shop. It consists of ring in circular cross section at the top end of the threaded portion. Okay, at the lower end. The threaded portion is screwed inside the threaded hole on the top surface of the machine to be lifted. A crane hook or chain is inserted in the circular ring. The circular ring is called a eye. This circular ring is called as a eye. The threaded portion of the eye bolt is subjected to tensile stress due to the weight being lifted. The threaded portion is subjected to the tensile load, subjected to tensile load because of lifting the weight. The threaded portion only we can get the tensile forces. First, step 1, we can find the permissible tensile stress. The formula of permissible tensile stress equal to sigma T equal to stress at yield strength divided by factor of safety. Yield strength equal to 400 Newton per millimeter square divided by factor of safety is equal to 6. Okay, so we can get the value of 66.67 Newton per millimeter square. This is the permissible tensile stress sigma T. And second step is find the size of the bolt. From the equation 1, as we have discussed in previous video, equation 1, sigma T equal to load by area of core diameter, because In core diameter only get the failure. Because of the uneven area or minimum area will get the failure in the bolt. Okay, so we can find the area of core diameter. P equal to load. How much load the bolt has to be lifted. So we can load is 10 kilonewton. Here DC equal to, we have to find sigma T, already we know 66.67 Newton per millimeter square. Apply this value to in this formula. Okay, sigma T equal to 66.67 equal to P equal to 10 kilonewton. Here the 10 into 10 power 3. The kilonewton is converted into Newton. So 10 into 10, 10 to power 3 divided by pi by 4 dc square. Solve this equation, we can get the value of dc. dc equal to 13.82 millimeter. And from this equation, equation 3, dc equal to 0.8 t. dc equal to 0.8 t. As we have discussed in previous video, dc equal to 0.8 t is the formula. You can apply the dc value 13.82 divided by 0.8. dc equal to, what is the value of capital diameter? 17.27 is say 18 millimeter. From the design data book, page number 5.42, we can get the actual bolt size. Standard size of the bolt is M20. Let's see here. D equal to capital D equal to 18 millimeter. Okay. After the 16 millimeter, okay, here is the major diameter. After the 16, standard diameter will be 20. So we can get the M20 bolt. This is the standard bolt we have to use for this. This is the outer diameter of the bolt is M20. Okay. From this DC also we can find the capital D value from this table. Okay. Here DC value is 13.82. Let's see, there is 13.82. This is the minor diameter. This is 13.546. So here 13.82. So this is the bigger than this value. So we can go for the next size. So 16.933. So what is the nominal diameter of this bolt is 20. Okay. So we can take the M20 bolt. This is core series. This is the fine series. Already in the problem they are mentioned course thread. Okay. So go for core series only. Okay. That's all. Okay. Let's see the next problem. Problem 2. Two plates are fastened by means of two bolts as shown in figure. This is the two plate, plate 1, plate 2 are fastened by the two bolt. This is the bolt 1, this is the bolt 2. Okay. The bolt are made up of plain carbon steel. The material of the bolt is 30 C8. The yield strength is 400 Newton per millimeter square. And the factor of safety is 5. Okay. Determine the size of the bolt if the load is, this tensile shear load is 5 kilonewton. Okay. Here the shear strength will be acted. The lateral force is acted here. So lateral load is acted here. So we can find the, we will find the shear load. Okay. The given data is P equal to 5 kilonewton. Okay. And yield strength is 400 Newton per millimeter square. Factor of safety is 5. What we are going to find? Size of the bolt. Size of the bolt means outer diameter of the bolt. Okay. The solution for step 1. Step 1, permissible shear strength. Here in previous problem load is acting as a tensile load. Here the load is acting as a shear load. Okay, okay, shear load is acting. Okay, because the load is acting perpendicular to the axis of the bolt here. Okay, let's see here. The equation shear strength equal to 0.5 yield strength. Okay, this is the formula. Through this formula, we can find the shear strength of the bolt. So 0.5 into 400. 400 is the yield strength. So we can find the shear strength of this bolt. Okay, and then shear stress. Shear stress equal to shear strength divided by factor of safety. Okay, tau equal to SSY divided by Fs. Okay, shear strength equal to 200 Newton per millimeter square divided by factor of safety is 5. You can apply this value to this formula. You can get 40 Newton per millimeter square. The shear stress is permissible shear stress is 40 Newton per millimeter square. And then step 2, find the size of the bolt. The shank portion of the bolt is subjected to the direct shear stress. Here the bolt is fastening the two plates. Here, let's see. Okay, this is the threaded portion. This portion is the shank portion. The shank portion is inserted in the plate hole. Okay, so here shank portion is subjected to the shear stress. Okay, so let the diameter of the shank to be denoted by the D. Okay, here we can find the capital diameter. In previous problem, in tension stress, the load is acting and stress is acting in the core diameter of the thread. So we can find the area of DC here in previous problem. For in this problem, the load is the shear stress is acting on the shank of the bolt. So we can find the outer diameter of the bolt because the shank of the bolt is equal to the outer diameter of the thread. Okay. Shear area of two bolts. Here two bolts are there. So shear area of two bolts equal to 2 into pi by 4 d squared millimeter square. Therefore, P equal to, load equal to shear stress formula here. Stress equal to load by area. Here load equal to 2 into pi by 4 d square into stress, shear stress. Okay, already found the shear stress value here. Shear stress is 40 Newton per millimeter square. Load is 5 kilonewton. Apply the value to this formula. 5 kilonewton is converted into Newton. 5 into 10 to the power 3 Newton. Apply this value and resolve this equation. We can get the D value. D equal to 8.92, say 9 millimeter. Okay. From the design data book, the standard size of the bolt is M10. Okay. Let's see the table. D value is 9 millimeter. After the 8, you will have the 10 M10 bolt only. We don't have the M9 bolt. After the 8, we can have only M10. So standard size of the bolt is M10. Okay. Thank you.